Hi and welcome to the math walkthrough on Cambridge IGCSE 2020 to 2022 Specimen Paper 4 58004. Question 1a. Christian and Stephanie share some money in the ratio of 3 to 2. Christian receives $72. Work out how much Stephanie receives. Stephanie's share would be 72 times 2/3. Next, Christian spends 45% of his $72 on a computer game. Calculate the price of the computer game. The price of the computer game is $72 times 45%. Question 1-3. Christian also buys a meal for $8.40. Calculate the fraction of the $72 Christian has left after buying the computer game and the meal. Give your answer in its lowest terms. In locating Christian's total spend, we can in a way calculate what's left, and the required fraction would be what's left over its original total. This, when simplified to its lower terms, comes to 13 over 30. Next, Stephanie buys a book in a sale for $19.20. This sale price is after a reduction of 20%. Calculate the original price of the book. A reduction of 20% is synonymous to the purchase being done at 80% of the original price. Hence, the original price can be calculated by taking the value in dollar being divided by 80%. Question 1b. Boris invests $550 at a rate of 2% per year simple interest. Calculate the value of the investment at the end of 10 years. Simple interest is 550 times 0.02 times 10, which is 110. The value of the total investment will be the simple interest plus the original investment. Next, Marlene invests $550 at a rate of 1.9% per year compound interest. Calculate the value of the investment at the end of 10 years. Its compound interest is 550 times 1.019 to the order of 10. Question 1d. Hans invests $550 at a rate of X% per year compound interest. At the end of 10 years, the value of the investment is 638.30, correct to the nearest cent. Find the value of X. This would be equating 550 times by the entire of 1 plus x to the order of 10, being equal to 638.30. Then solve for x. Question 2a. 200 students estimate the volume VM cube of a classroom. The cumulative frequency diagram shows their results. Use the graph to find an estimate of the median. This is the value of x when the cumulative frequency is at its midpoint, this being 400. Next, use the graph to find an estimate of the interquartile range. This will be the difference in x value when its y value is at 75% and 25% respectively. This comes to 70. Next, use the graph to find an estimate of the 60th percentile. This is the x value when the cumulative frequency is 60% of its maximum. Next, use the graph to find an estimate of the number of students who estimate that the volume is greater than 300 meters cubed. From the graph, when x is 300, y is 30. Therefore, the required number of students is 200 minus 30. Question 2b. The 200 students also estimate the total area A meter square of the windows in the classroom. The table shows their results. Calculate an estimate of the mean. You must show all your working. This is the sum or product of the midpoint of its area against its associated frequency and the total being divided by 200. Next, complete the histogram to show the information in the table. Here, the height of each bar is its frequency divided by the midpoint of its area. Next, 2 students are chosen at random from those students that estimated the area of the windows to be more than 100 meters square. Find the probability that one of the 2 students estimates the area to be greater than 150 meters square and the other student estimates the area to be 150 meters square or less. With only students that estimated the area of the windows to be more than 100 meters square, the pool is really just 80 plus 24. The required probability is the sum of when it is greater than less, plus when it's less than greater. This is equal to 80 over 104 times 24 over 103 times 2. Question 3. Fx is 20 over x plus x, where x is not equal to 0. Complete the table. They come up to 9 and 10.5 respectively. Next, on the grid, draw the graph. This would be plotting the coordinates provided from the table. Next, use your graph to solve for the equation fx equals 11. This would be the x values when y is 11. Next, k is a prime number and fx is k has no solutions. Find the possible values of k. These are the values of y equals k that are not intersecting the curve, with specifics of k being a prime number. Question 3e. The gradient of the graph y equals fx at the point of 2 and 12 is minus 4. Write down the coordinates of the other point on the graph of y equals fx where the gradient is minus 4. The graph having a rotational symmetry of 180 degrees with center at 0, 0. The required coordinates are minus 2 and minus 12. Question 3f. The equation fx equals to x squared can be written as x cubed plus px squared plus q equals 0. Show that p is equals to minus 1 and q is equals to minus 20. This can be shown by equating 20 over x plus x being equal to x squared and rearrange in accordance. Next, on the grid opposite, draw the graph of y equals x squared. This is the added plot on the diagram. Next, use your graph and solve the equation x cubed minus x squared minus 20 equals 0. This is purely the value of x for the intersect of the two curves. Question 3f4. The diagram shows a sketch of the graph of y equals x cubed minus x squared minus 20. P is the point n 0. Write down the value of n. This would be solving for x when y equals 0. Taking the answer from the previous question where x is 3.3, we could take on sensible values of x for the required refined answer. Question 4a. Draw the reflection of triangle T in the line x equals 0. This is the added blue triangle on the diagram. Next, draw the rotation of triangle T about the coordinates minus 2, minus 1 through 90 degrees clockwise. This is the added triangle on the left. Next, describe fully the single transformation that maps triangle T onto triangle U. It is a translation along the vector 1, 6. Question 5a. The perimeter of the rectangle is 80 centimeters. The area of the rectangle is a centimeter square. Show that the given equation is correct. With the perimeter being 80 and one of its dimension being x, the other could be identified as 40 minus x. With that, we could set up the area equation as x times 40 minus x being equal to a, and rearrange this equation in accordance to get to what is required to be shown. Next, when a is 300, solve for the equation by factorizing. By equating a as 300 into the equation, we can factorize the equation to solve for x. Next, when a is equal to 200, solve the equation using the quadratic formula. Show all your working and give your answers correct to 2 decimal places. With a being 1, b being minus 40, and c being 200, we could solve for x. Question 5b. A car completes a 200 kilometer journey at an average speed of x kilometers per hour. The car completes the return journey of 200 kilometers at an average speed of x plus 10 kilometers per hour. Show that the difference between the time taken for each of the two journeys is as stated. By subtracting the time for journey back from the time for journey to destination, we can get to what is required to be shown. Next, find the difference between the time taken for each of the two journeys when x equals 80. Give your answer in minutes and seconds. With x being 80, the expression is 1000. This is equivalent to 16 minutes and 40 seconds. Question 6. OPQR is a rectangle and O is the origin. M is the midpoint of RQ and PT to TQ is in the ratio of 2 to 1. OP is P and OR is R. Find in terms of P and OR in its simplest form. What is MQ? MQ is half P. Next, find MT. MT is equals to half P minus a third R. Next, find OT. OT is equal to P minus 2/3 of R. Question 6b. RQ and OT are extended and meet at U. Find the position vector of U in terms of P and R. Give your answer in its simplest form. With the ratio of PT to TO being equal to RQ to RU is 3 over 2P. Hence, the required vector is R plus 3 over 2P. Next, with MT having the vector 2K and minus K, and its dimension being a root of 180, find the positive value of K. The information can be used to set up the Pythagoras formula, then solve for K. Question 7a. Solve the equation fx equals g1. By doing the maths, x is 2. Next, find the inverse of the function of x. By letting y being equal to the function of x and rearranging the subjects such that x is expressed in the form of y, the inverse function of x can be identified. Next, find the function of gf in its simplest form. By doing the maths, the function of gf is 4x squared plus 4x plus 5. Question 7d. Solve the equation of the inverse of h being equal to 0.5. Knowing that the coupling of h and its inverse function is x, we can solve for x. Next, write down the value of k for the given equation. By expressing both sides of the equation as a base 2, we could solve for k. Question 8. The grid shows the graph of y equals cos x for the given range. Solve the equation 3 cos x equals 1 for the given range. Give your answers correct to one decimal place. By performing the maths, x can be identified as being equal to 70.5 and 289.5. Next, on the same grid, sketch the graph of y equals sine x for the given range. This is the blue curve on the diagram. Question 9. The diagram shows a trapezium ABCD. AB is parallel to DC. AB is 55 meters, BD is 70 meters, angle ABD is 40 degrees, and the angle BCD is 32 degrees. Calculate AD. AD can be identified by applying the cosine rule. Next, calculate BC. BC in turn can be identified using the sine rule. Question 9c. Calculate the area of ABCD. The required area is equal to the sum of the two triangles. Next, calculate the shortest distance from A to BD. The shortest distance would form the right angle triangle ABE and apply simple trigonometry, where sine 40 is equal to AE over 55 to solve for AE. Question 10a. Show that the volume of a metal sphere of radius 15 cm is 14,140 cm cubed. Correct the four significant figures. We can show this by applying R equals 15 into the given formula. Next, the sphere is placed inside an empty cylindrical tank of radius 25 cm and height 60 cm. The tank is filled with water. Calculate the volume of water needed to fill the tank. The required volume is the volume of the cylinder minus that of the sphere. Question 10b2. The sphere is removed from the tank. Calculate the depth d of water in the tank. E would be the height of the cylinder when its volume is equated to that of the sphere. The required value of d is 60 minus E. Question 10c. The diagram below shows a solid circular cone and a solid sphere. The cone has radius 5x cm and height 12x cm. The sphere has radius r cm. The cone has the same total surface area as the sphere. Show that r squared is equal to 45 over 2 x squared. We have to start with the use of the Pythagoras formula to find its slanted height. Next, we equate the formulas for the surface area of a cone with that with the surface area of a sphere and perform the required arrangement to get to what is required to be shown. Question 11. The curve has the equation y equals x cubed minus 6x squared plus 16. Find the coordinates of the two turning points. The turning points are where its gradient is 0. That is when its dy dx is equal to 0. With the equation being converted to its dy dx, we can solve for x. With the identified x's, we can solve for each of the values of required y that are associated. Next, determine whether each of the turning points is a maximum or a minimum. Give reasons for your answers. Here are two methods for the required determination. First, the curve would be shaped as shown. Hence, the one with the lower x value would be that of a max, and that with a higher x value is a min. In the second method, when x is equal to minus 1, y is lower than 16. This means that 0, 16 is the max, as the point beside it has a lower value of y. Likewise, when x is equal to 5, y is equal to larger than minus 16. Hence, for the coordinate 4 minus 16, it is a minimum because the point beside it has a higher value of y. We have reached the end of this walkthrough. Do be on the lookout of our other walkthroughs if you have found this beneficial.